All right, so I was sick last week. I had to go to the hospital, but I was able to put some stuff together. So if there's any gaps in my knowledge, apologies in advance.
You feeling okay now?
uh,
You're just gonna drop the hospital bomb and move on to.
yeah, no, I mean I'm fine. I'm fine. They check me out. Everything's cool. Like my problems are not. They're like you're not gonna die, and we can't help you here. So get out of here. So I was like, all right. So I gotta go and see a real doctor. Then
Here's a bill for $10,000.
yeah, America, fuck yeah. All right. So Celestia doesn't have light clients per se. Their version of a light client is actually a light node. It's the primary way of interacting with the Celestia blockchain. And so since it leverages some of the infrastructure of the blockchain, I was going to talk about their modular blockchain architecture in general before I actually get to the light node. So can you see this stuff? So monolithic versus modular.
Yep.
So they make a distinction between a monolithic blockchain in that you have a consensus layer handling execution, settlement, and data layer. So it's not optimizable in their eyes. And they move to a modular architecture where you have an execution layer, settlement layer, but the consensus layer is around a data availability layer. And that will show up later in, wait, let's just go forward, go back. Okay, so what's important to understand is that light nodes, the way that they do verification is they download it. So, okay, let's back up. So they use a version of Tendermint as their consensus layer. The augmented version of Tendermint that they use has erasure coding and the ability to namespace Merkle trees. So it's a partitioning of namespace. So you don't need, if you have a namespace, then if an app has a namespace in the that's partitioned, then it only has to be concerned about the data within that namespace. And then the erasure coding, if you're not familiar with that, it's like if you have a CD with 1 megabytes of information, you can blow it up to 2 megabytes of information. So it's a kind of like way of being able to create like data that's missing from data that's there. And what is sent to the light node so the Celestia core is actually the augmented Tendermint consensus layer. It takes the executable transactions and the blob transactions, and it creates a wrapped block header. So what it actually emits for the light nodes to pick up is in a block header, the new block header, when the new block's available, it's an extended header that has the executable transactions and the blobs as data in it, and also the header. And the way that it's able to transfer like all this block information to the light nodes without it being crazy is it uses this 2D Reed-Solomon encoding to create a two-dimensional data primitive that the light node can sample in order to verify that the block is a valid block. So rather than, so each of these light nodes has to download this, this data, and then it samples it, and then it's able to take from the samples, determine that the block is actually a real verified block. I can't remember like what how it improves, but like it's like one sample like means that 25% is verified, but like if you get up to like 7 data samples, then it's 99% of the block is verified. And in that way, the light node is able to do the verification itself. It just needs to download this data, this extended header from the consensus layer. So you can send transactions with the light node. What the setup for the light node is actually a wallet that gets created that has that you can fund and you can use. and it's really small. And because they're relying on the architecture of Celestia to like do all this, I don't know like what you can take away from it for Beerus. And I'm not a mathematician, so I don't know how much, like if you take data sampling as like you know, a way of like verifying like a large like, you know, Merkle tree or proof or whatever. Like if, you know, if you take stored proofs of like different, like a subset of like, you know, something, I don't know, in order to like verify a larger state. I'm kind of waffling, but yeah, I mean, so that's basically what Celestia is about.
That's actually super interesting because Ben and I were talking about some stuff related to erasure coding and exactly what you just showed us. And I'm just wondering how, by sampling, they can deduce that the data is proven or is valid. This is very interesting. This is very interesting because the way you fragment your data is one part of, as you said, mathematics, and it's very interesting the way you can split the data and then reconstruct even if some fragments are missing. This is huge as a technology, but that's just, you know, strike me, and I just want to understand how they can, because you already explained some stuff, but that's very interesting. How can they prove, or how can they trust something just because it's reconstructable, is reliable, or there, you know, it's like it's super interesting, super interesting.
Yeah, so the consensus layer can replay all the transactions at any point in time and verify the block. So I mean, like, and that's all. I mean, I think that, yeah, I don't know. I since I didn't have time to like learn Golang and go and go through their code.
No, that's already very nice to have, you know, the insight of how they are doing it. So that's actually very cool.
I think for Beerus core, at the end of the day, just trying to, you know, do these things like we've said, just keep it as simple as possible for on the Beerus side. I do think, at least for the short term, this kind of like erasure coding scheme doesn't make a ton of sense. That being said, Glim has a project called Potara FS that implements it, or at least the goal is to implement some of this kind of stuff. So I do think that it makes sense to live in the ecosystem, but maybe not in-house in Beerus. Glim, do you still have that document around Potara?
I just have the notion, but I am getting back on this, so I will be able in the few weeks to be able to pre-post some, you know, more illustrated stuff. But I do agree on what you said, and because I think for us in Beerus we can prove more easier than even without thinking about erasure coding on fragments. But it can definitely, you know, complement in a way how data is available.
The one takeaway that I thought would be nice to incorporate, I liked that they, from their perspective, like the main way to interact with their blockchain is through a light node rather than, you know, requiring a full node, you know. So I don't know if that was like, that would be like a nice, like kind of guiding light as far as like, hey, everybody should be interacting with Starknet using Beerus. You know, this is the way to do it, and our infrastructure supports it. I don't know, but I again, like keeping it lightweight. It's, you know, whether through erasure coding or data sampling or whatever. You know, I don't know how to do that with the way that we have it configured currently. So
I do think that would be awesome. In my opinion, like the state needs to be held somewhere by somebody. So in that scheme, it sounds like it is just an erasure coded state. So then, you know, that is how they implement that, like primary interface being the light client. So yeah, I think if you were going to step away from, like, you know, all of the state being held on a full node, you would essentially have to erasure code the full node, which would be something similar to Potara, I think.
Mm-hmm. Yes, but as you said, Alex, like if you can just have Beerus and you can go through Beerus to access all of the Starknet easily, and that can be a very nice motivation and something we can propose. And about the fragmentation of the data is just more for data availability, and be sure that we can, you know, spread the data and not only relying on full node, as Ben is saying, and being a bit more, you know, reliable and robust in the future.
Sweet, that was awesome. Thank you, Alex.